for lesson 4. Okay, so the equation of a line, slope y-intercept form, y equals mx plus b. In this unit, we express the equation of linear relation in 3 different forms. Okay, so this is what you guys, I'd highlight this if I was you, because on your test, it'll ask for a form. If you don't know the forms, you don't know what it's asking. Okay, so one is slope y-intercept form, that one there. Okay, you have slope y-intercept form, point slope form, and general form. Those are the 3 forms that you're going to have to get familiar with. Okay, we also determine the linear relation given a graph, a point, a slope, 2 points, a point, and the equation of the parallel perpendicular line. So in summary, what that's saying is they're going to do a lot of things. So they say, here's the slope, it goes to this point. What's the equation of the line? We're going to get the tools to be able to figure that out. Okay, or it's going to say, find the equation of a line that's parallel to this line, but goes through this point. So you'll steal the parallel line slope because they're the same, right? If they're parallel, they have to be the same. And then you'll do the same work. So they're all like the same question, just little tiers of differences. Like, again, I just said the same thing twice, essentially. If you're given the slope and a point, you can find it. If I say you're parallel to this line, but here's the point it goes through, you just steal the slope, and you're back to the slope and a point, and you find it. Okay, so a lot of things we're going to be doing is related to my point. All right? Okay, so let's just look at some things here. I won't throw too much at you at once here. Okay, investigating the graphs of linear non-linear relations. So the equations of graphs of some relations are given. Excuse me, talking too fast. In each case, use a graph calculator to sketch the relation. So do not list any x or y intercepts. You don't have to list anything. We're just sketching the graph. So go ahead and just practice on punching these into the calculator, and just so you can see which ones are linear and which ones aren't. Okay, I'll give you a second, but I kind of know these already. So 3x plus 1 will look something like that. Negative 2x plus 3. Negative x cubed plus 1. Switch the pen for this one here. X squared minus 3. One over x. One half x minus 2. Oops. Four x. And then 2 to the x. Okay, you can keep punching maybe you want for practice, but that's what they look like. Okay, and then at the bottom there it says linear versus nonlinear. So right there where I can still write on my board here, which ones are linear? We'll just number them. So we got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so Lauren, give me one that's linear. Number 1, good. So number 1 is, so this one here, linear. Okay, good. Stanich? 2. 2 is also linear. Okay, Raj, what's another one that's linear? 6, good. Okay, and then Travis, what's the last one that's linear?
4.
No, 4 is a parabola, it's curved. Oh, 4 is a parabola, it's curved, so it's not linear.
7.
There we go. Yeah, 7 right there. Okay, so then the other 4 are not linear. Okay, remember we kind of talked about this. This is a quadratic. This is a parabola. Okay, the post is behind, so that's not linear. Okay, this is a cubic, also not linear. Has 2 curves in it. This has 1 curve in it. This one's a broken graph. Okay, this is a rational expression, and we are doing this in Math 20 right now. This is created because of asymptotes, but you'll learn about that some other day. Okay, so this one is not linear. And this one's exponential, so it's not linear. Okay, so if you guys remember from Math 9, 2 to the x is that beetle problem that was in the book. I talked about the beetles are growing exponentially, so they double, they keep doubling, so it grows really fast. That's why this thing's kind of slow, and it takes off. We've talked about exponential in Math 9. So, okay, all right, perfect. So C, compare the list, write a rule from the equation. So why are the ones linear compared to the ones that aren't? What do you think, Denise? Just give me a guess. Why are the ones linear, the linear ones, opposed to the ones that aren't, in terms of their equation? What? Right, they all just have a single x. X cubed, x squared, 1 over x, so that's over, that's division of x, so that's not an x. Does anybody know? Let's see here. We should. Correct. This right here would be x to the negative 1. So that's why it's not a single x. That's exactly what I was going to ask. Good job, Luke. Single x, 2 to the x. So it's an exponent in the x. Okay, so good. That is the correct. So down there at the bottom there, linear equations have a x to the 1. There's nothing else, just a single x. And we will be dealing with them in this form. Y equals mx plus b. We're going to say that a bajillion times this unit. Y equals mx plus b. We know what the m stands for, right? What's m? Slope. And then b? Y-intercept. Good, Lauren. B is the y-intercept. Okay, we'll talk about that some more. That's not in the Math 9 curriculum, but Mr. Moore, I think, talked about it more than I did. So, good. Let's do warm-up number 2. Investigating m and b in the equation. So, Janine used a graph calculator to sketch 2/3 x minus 1. Use a sketch in points a and b to find the slope and y-intercept of the graph. See what we can see. Where does it cross? What's this point here? Negative 1. It's crossing at negative 1. So the y-intercept is negative 1. Well, let's count the slope. Up 1, up 2, 1, 2, 3. So we're just kind of putting together the m is slope, the b is the y-intercept when you have it in slope-intercept form. Okay, compare the values found in A at the coefficient and the constant term of the equation. Just they're the same. So this right here could just go right there. M is 2/3. B is negative 1. Okay, let's see what she's doing down here for C. Janine sketched the graphs of 2 more linear equations. Use the grid to determine the slope and the y-intercept of each. Okay, so she has y equals 2x plus 1. So what's the slope of that ridge? 2x plus 1. What's the slope? 2. Right. The number next to the x. Okay. Good. What's the y-intercept, Maddie? For 2x plus 1. No, this 2x plus 1. 1. Okay. So I'm asking these because, guys, they're right on the equation. Okay. So I think we missed this. Let me say it again. This is the slope-intercept form. Okay, y equals mx plus b. Yeah, you good? Okay, so here, this number in front of x, which is our m, is our slope. That's what Ridge told us. In front of x is our m, which is slope. This number b is our y-intercept. This number here by itself is our y-intercept. That's what Maddie told me. So you read it right from the graph when it's in slope form. Okay, all right, perfect. So Noah, what's the slope here? Negative 5 over 2, perfect. And then what's the y-intercept, Aiden? Good. Minus 3 is important. It's not a 3, it's the negative 3. So he's right on that. Okay? All right, so make a conjecture about the slope and y-intercept of the graph of the linear equation. Your conjecture is simply m is slope, b is y-intercept. That's all it is. They're being very redundant here. Okay? We've got one more little warm-up piece, and then we're going to get to some examples. All right, so we're focusing on just y equals mx plus b for the most part. So has she used a graph calculator to graph the linear equation 2y equals 5x plus 8? The graph is shown on the grid. Question: is it currently in a form that we can put in our calculator? Why? Because it's 2y. Does everybody see that? You can't put 5x plus 8 and it won't give you the right graph. So what you have to do is what? You have to get y by itself to put in your calculator. And how would you do that? Yeah, divide everything by 2. Just letting you know, if you're putting this in your calculator, it's divide 2. So it's actually this. And that's why it's going through 4. 1, 2, 3, 4. That's why it's up 1, 2, 3, 4, 5 over 2. Okay, questions there? Okay, so use a sketch to determine the slope and y-intercept. So what we did essentially is we cheated. We got it here already. We know it's this. So the slope is 5/2. The y-intercept is 4. Explain why in this case the slope is not 5, and we just talked about that because y is 2y, not y by itself. Okay, it's 2y, not y by itself. That's all you have to say. Okay, we're good? All right, let's get this thing tied up here. You guys are doing a good job. Thank you. Slope y-intercept form. So again, this is called slope y-intercept form. So I definitely would highlight this right here, or definitely mark this as one of the forms you need to know. Okay, so when I say, if I say, Aiden, please give me the answer in slope y-intercept form, and he gives to me in general, that'll be wrong. Okay, so you have to know your forms. Okay, that's half the battle here. Okay, again, I personally, just for me, I like slope-intercept form the best. You can see everything. You can see the slope, you can see the y-intercept. Okay? All right, so let's look at these here. Where did Aiden? So Andy, determine the slope and y-intercept of the equations below. So what's the slope and y-intercept of A? For Andy? 3 is the slope or y-intercept? Good. So m is 3, and what's the y-intercept? 2.
For a slope, would you put like 3 over 1?
You can. You don't have to put 3 over 1, but when you're counting, you'll count 3 over 1. Okay, do you guys hear that? He asked you to put 3 over 1. You can, but when you're counting, he's exactly right, and I was actually going to show you this. If you do 2, that's where I start, right? Because 2 is the y-intercept. And from here, I go up 3 over 1. I only need 2 dots. I have enough to make a line roughly now. Yeah, Luke? Doesn't matter. M or slope. M means slope, but you can also just call it slope. Okay? So Logan, they switched on you. B, what's the slope?
-2.
Right, it's not 7. It's the thing next to the x. Doesn't matter where it's at. It's the thing next to the x. Okay? B. Okay, what's B going to be, Logan? Good. Ollie, for this one, what do you have to do to figure it out? Divide them all by 6. Good job. So y is 4 over 3x plus 1/6. So then we'll spin it off to Spencer now. Spencer, what's the slope after we do that work? Good. Perfect. Nice, nice, nice. All right, last page. All right. All right, consider the equation. Y equals 2x minus 5. Okay, so take the slope and the y-intercept. Okay, so I'm going to do this part. You guys are probably getting tired of this. Slope is 2. Y-intercept is -5. mark the y-intercept on the grid. So let's go mark it on the grid here. -5. Right there's my dot. Use the y-intercept in the formula for rise of run to mark other points. So we know if the slope's 2, it's going up 2 over 1. Up 2 over 1, up 2 over 1. And that's all you have to do. And then from here, we can go ahead and we have enough dots to make our line. My line's a little bit off, but pretty close. Okay, so that's what it would look like. Verify the graph using the graph calculator, so you can put this into your calculator, just making sure that you're right. You guys can skip that for now. You're right. Okay. Okay, I want you to try example 3 on your own real quick. I'll pause the video. I want you to try this one. Make sure you get this right. If you get this right, you're good to go for today. So 2/3 x minus 6, state the y-intercept, -6, no problem. Whoa, arrows. -6, so I'm going to go and put my dot down here at -6. That's where I'm starting. Determine the x-intercept algebraically. So that's how you do it. You make this a 0. So I go 0 equals 2/3 x minus 6. I add 6 because I'm solving for x. Divide the 2/3. So it's going to be 6 divided by 2/3 equals x. That's just fraction work. You flip and multiply, which is 18 over 2, which is 9. So 9 is your x-intercept. Right there. Did I do that too fast? Okay. Mark the x and y-intercepts. We just did that. Join them together. So that was good. It's a pretty straight line. Okay. Then you can just kind of track it here. It's up 2 over 3. Up 2 over 3. Up 2 over 3. Okay. All right, that is it.